Which compound gives proton NMR spectrum with the following signals? 6 hydrogen doublet. Now, you know when it says 6 hydrogen doublet, we should have this group CH3, CH3, a hydrogen. And then also we should have one hydrogen septet. Do we have that? Yes, that's one hydrogen septet for this hydrogen right there. And then the 6 hydrogen doublet is for the 2 methyl groups. And then we also have 2 hydrogen quartet, 4 we have 3 hydrogen triplet and 2 hydrogen quartet. So 3 hydrogen triplet means you need to have this part CH3 next to a CH2. These 3 hydrogen would be a triplet due to these 2 hydrogens. And then these 2 hydrogen would be a quartet due to these 3 hydrogens, n plus 1. Now we have this part also. Now we need to put them together. That's all we have. And then we can have any other oxygen or carbonyl groups in the molecule. Okay. And we figured out how they are connected due to the chemical shifts. Now let's look at one hydrogen septet is at 4. Okay, meaning this hydrogen should be closer to an electron withdrawing group like oxygen. If it is closer to carbonyl group, that's about 2.1. But if it is closer to oxygen, that's about 3.2. But if it is closer to a group like this, oxygen and also carbonyl group, any hydrogen on this carbon is come around 4 ppm for the chemical shift. Okay. Now let's look at our A answer. There are 3 methyl groups on that carbon, and then you have CH2, CH2. Okay, let me draw that molecule for you, so then you will see that why it's not the correct one. Come on. Okay, good. Okay, so let me draw that. So this is how A look like. So you have a CH3 group, and then you have another CH3 group. That's why it says 2, and then it also has a hydrogen on it. And then you have a CH2 group, and then you have a oxygen, O2, and then a C, meaning oxygen, and then you have a carbonyl group and CH3. So this is A. But see, do we have in the pieces that you found, do we have a 3 hydrogen singlet? No, right? Because we just draw in the green color what we have in our given data, with the given data. But this one tells us 3 hydrogen singlet. That's not true. And also here we should have a 2 hydrogen doublet, because these 2 hydrogen would be a doublet due to this hydrogen. We don't have that information in our given data, so A is not the correct answer. So A is out. Okay, A is not the correct answer. Now let's look at, so A is gone. And what about B? So if you draw B, there would be CH3, CH3, hydrogen, and then you have a CO2, meaning carbon comes first, and then the carbonyl group, and then the oxygen, then CH2, CH3. Now in this molecule we have this part CH2, CH3, it corresponds to this, and also we have the other green part also with this part. It looks like the correct molecule, but you have to look at the chemical shift. Now if the 2 hydrogen over here, CH2, going to be next to the oxygen, it should have a higher chemical shift. So 2 hydrogen quartet. 2 hydrogen quartet is at 2.2. 2 hydrogen quartet, this one is at 2.2. And then 4 at 4, 1 hydrogen septet. So 1 hydrogen septet over here should be 4 ppm. So in the structure that I have just drawn, CH2 is next to the oxygen. So then this CH2 should be somewhere around 4 ppm. But the given data has only 2.2 ppm. So this is not the structure either, even though the pattern is okay. But the chemical shift does not match with the drawn molecule. So that is not the structure either. Okay. And then we have the next one. We have CH3. CH3, this is C, okay, I'm drawing C, CH3, CH3, and then you have a hydrogen there, and then you have oxygen, CH2, CH3. If the two carbon, so if this carbon and this carbon, if the structure is like that, both this hydrogen and these two hydrogens should have about roughly the same chemical shift. It would be little bit different, somewhere around 2.1, but this would be little, if this is 2.3, and then this would be like 2.1, something like that, because it's the oxygen. But this would this hydrogen would have a higher chemical shift because it has two methyl groups, whereas this one 2.1 will have only two hydrogen and one methyl group. Remember, the more carbons you have, it would be higher in frequency due to the carbon being more electronegative compared to the hydrogen. But we do have a prominent chemical shift change in the given data, 4 and 2.2. So it should not be this molecule either, having oxygen in the middle. And then we have another structure, D. Let's draw D. So the D going to be CH3, CH3, H, and then you have O2C, meaning oxygen comes, then carbonyl group, CH2, CH3. Now we're going to see if we can identify the patterns that we have. So CH2, CH3 group is also there from the given data. And then this part, CH3, CH3H, that's going to be this part right there. What about the chemical shift? So this carbon is given to us as 2.2. And then this, not the carbon, I mean the hydrogen chemical shift, okay? And then this hydrogen is given as 4 ppm, which makes sense because this hydrogen is closer to oxygen, and this is given as 2.2 because now this is closer to a carbon. So electron withdrawing ability, oxygen is more compared to carbon. So the hydrogen closer to the oxygen would be having a higher chemical shift compared to the hydrogen closer to the carbonyl group, 2.2. So which makes sense. So the molecule D would be the correct answer for that. Okay, and just for the fun of it, let's draw the E and see how it looks. Come on. Okay, so let's look at E. E, you have CH3, two groups, CH, CH2, CO, O, CH3. So this molecule doesn't have the pieces that we found that the molecule should have. So this will give you a 3-methyl singlet, but we don't have that. And then this should give us a 2 hydrogen, this should give us 3 hydrogen singlet, we don't have that. And this should give us 2 hydrogen doublet, we don't have that piece of information given also. So E also not the correct one. Okay, so that's how you figure out how to draw the molecules from the condensed structure, and also to see the pattern of the pieces as well as the chemical shift. So the correct answer is D in this case. And number 20. What split-in pattern is observed for the indicated hydrogens? So the indicated hydrogens, if you draw this molecule, so you can draw CH3O, CH2, CH2O, CH3. So the indicated hydrogen is this guy. What do you think is going to be the splitting pattern? Okay, so look at the molecule and find out if you have any symmetrical carbons, meaning the same environment. So these three hydrogens and these three hydrogens are going to be in the same environment. Do you agree with me? Because they are next to the oxygen, and then it's the same groups that's going to meet. And what about these two carbons carrying hydrogens? Those four hydrogens. They are also chemically equivalent, aren't they? The molecule is symmetrical. They are chemically equivalent hydrogens. Normally, the chemical equivalent hydrogens don't split each other. So as a result, those hydrogens, it would end up being a singlet. You would expect these two hydrogens split due to the neighboring hydrogens to a triplet. And then these two could split due to two hydrogens on the neighboring carbon to a triplet. But since they are the same environment, they do not split each other. They would only give us a singlet. Okay, so the correct answer is A, as a singlet. Now 21, which of the hydrogens gives NMR signal with the lowest frequency? Remember, we talk about the highest frequency would be when it is closer to the more electronegative atom, fluorine. And then the next highest one would be the one closer to bromine, would be this one. And then if the hydrogens are further away from the electronegative atoms, it would give us the lowest frequency. So in that case, it would be this hydrogen, right? Because this is the furthest hydrogens, and this would be the next. So this one right there would be the lowest frequency. What's the answer then? Okay, so the numbering, look at the numbering. Numbering little confuses in this PowerPoint, but you can see carbon number 1 is this. Carbon number 2 is this. Carbon number 3 is that. Carbon, how many carbons? 1, 2, 3, 4, 5. Carbon number 4 is this. And carbon number 5 is this. So which carbon it is going to be then? Number 3, which is C. Okay. How many signals that the proton number, proton NMR? 4-methyl 1-propyl benzene. So we need to know how to draw the molecule. So this is benzene. And then you can start numbering. 4-methyl 1-propyl benzene. If you give this carbon 1, that's a propyl group, meaning 3 carbons. So 1, 2, 3. 3 carbons, propyl group. And then on the 4th position, you have a methyl group. 1, 2, 3, 4. 4-methyl 1-propyl benzene. How many signals? So we will have 3 hydrogens. They are going to be a 1 signal. 2 hydrogens would be another signal. These 2 would be another signal. And this is going to be another signal. And what about these? They are going to be in one environment since the molecule is symmetrical. So these are going to be in another environment. So how many total signals we're going to have? 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6. So 6 signals. 22. C is the correct answer. Okay, 1 and 4 doesn't have any hydrogen on it. How many signals would you expect to see the proton NMR of the following one? We have Cl, CH2, CH2, Cl. Cl, CH2, CH2, Cl. These two are, now you know they are chemical equivalent. They would not be in two different environment. So it would be only one peak. Okay. I hope this helps to you guys. Well, I think I didn't do number 7. Let me go ahead and do number 7 for you guys. Okay, let me backtrack. Number 7. Oops. Okay, so let's do number 7 here again. Okay, so you can refer to the question number 7. I cannot show it to you because there are some pen marks and it doesn't delete by now because it's already been saved like that. But let me show you. It's asking, okay, so number 7. Number 7 is which of the following with the highest frequency. So you have a molecule like this, CH3, carbon, CH3, hydrogen, and then you have oxygen, CH2, CH2, CH3, and these are numbered. It was numbered differently or whatever. So here we have number 1 is going to be this carbon. Number 1, 2, 3, 4, 5. Okay, which one is the one with the highest frequency, meaning which one would be the more de-shielded one? Which one do you think? The whichever closer to oxygen electronegative atom. So we have two choices, either 2 or 3. So we need to figure out between 2 and 3 which one is going to be the most de-shielded one. Remember, number 2 carbon carrying hydrogen has 2 methyl groups on it. 2 methyl groups on it, whereas the carbon 3 has 1 ethyl group. If you remember, between the electronegativity of carbon and hydrogen, carbon electronegativity is 2.5, hydrogen electronegativity is 2.1. So carbon is more electronegative compared to hydrogen, meaning more carbon groups you have on a carbon carrying hydrogen would be more de-shielded compared to having less number of carbon groups or more hydrogens. Okay, so 2 has 2 methyl and 1 hydrogen, 3 has 1 ethyl and 2 hydrogens. So because of that, 2 would carry B. Answer B, or the 2, carbon 2 would be the highest frequency one, and that is one question number 7. Okay, all right, that's it.